For a very long time, humans have imagined what life may be like on other worlds. Interest in Earth 2.0, our planet's twin orbiting within the habitable zone of its star. Searches have so far turned up nothing, prompting scientists to use their imagination to find another potential planet for life in the universe. The James Webb Space Telescope has now provided the answer to that question. The world's most powerful telescope will offer new resources to address the age-old question of whether there is life elsewhere in the universe. Explore James Webb's startling discovery of city lights, which alters everything with us. The only life that we are currently aware of is on Earth. Since the beginning of civilization, people have questioned whether there is life elsewhere in the universe. Extraterrestrial intelligence. A search for American astronomers, Jill Tada and Thomas Pearson, established the SETI Project in 1984 to carry out such interstellar searches. The nonprofit's objective is to gather spaceborne radio signals. Radio waves can travel further and are therefore more likely to be detected by the 42 radio telescopes that make up the unique Allen Telescope Array in the Californian Cascade Mountains because they are less dispersed or absorbed than other types of radiation. But in the past 30 years, no verifiable alien signal has been discovered. Following that, the James Webb Space Telescope, JWST, the largest telescope in the world, will investigate a range of distant, unexplored planets orbiting far-off stars. The JWST is floating roughly 1 million miles from Earth and is outfitted with very sensitive detectors. There were no known planets 20 years ago, other those in our solar system. But since then, more than 40 more planets, also referred to as exoplanets, have been discovered orbiting other stars. According to NASA, the cosmos may contain trillions of exoplanets. The earliest proof that life exists outside of our solar system may come from extraterrestrial planet life. The spacecraft turned its equipment back toward Earth when it was en route to Io and found a definite indication of the presence of plants. The system detected a mixture of red and infrared light reflected by plants. For instance, if there is an Earth-like planet covered in rainforest, it should produce a high V-Re signal that is easy to find. Long-distance Earth-like planets in the habitable zone of stars will have their V-Re measured by the JWST. The atmospheres of exoplanets may hold important signs of life. When sunlight crosses a planet's star, the JWST may be able to detect it as it enters its atmosphere. The light's missing wavelengths would then be discovered. The atmosphere's atoms and molecules absorb specific wavelengths using spectroscopy, creating a characteristic fingerprint that the JWST can identify. This method may be used to determine the composition of the atmosphere and determine whether life is possible. It seems likely that life may exist on Earth-sized planets with atmospheres similar to our own, with a concentration of oxygen, nitrogen, and carbon dioxide. Additionally, it might be feasible to detect technological life by looking for elements that don't naturally arise. Chlorofluorocarbons, CFCs, created for use in cleaning supplies and refrigeration, are likely to be noticeable to aliens who are watching Earth's atmosphere from a distance. If the JWST found CFCs in planetary atmospheres, that would be a clear indication of a civilization. Exoplanet life may not even somewhat resemble life on Earth. Even earthly life, like species of extremophiles, can occasionally seem alien. This is a category of organisms, usually bacteria, that can endure in environments where other living things would not be able to. Some of them can withstand heat up to 250 degrees Fahrenheit. Others are able to guarantee low temperatures of -4 degrees Fahrenheit. On Earth, there are some that live in environments where we would not expect to find any life at all, including some that are able to withstand strong acids with pH values below 3. To begin with, it would be sensible to focus on planets that are similar to Earth because they are more likely to support life than worlds with arid or acidic conditions. Prime candidates could have temperatures that allow liquid water to exist on their surfaces and circle a stable star. In August 2016, astronomers discovered a planet with a mass of 1 to 3 Earth masses. It is possible that Proxima b is a lifeless, airless planet, given that it orbits its dim red dwarf star, Proxima Centauri, at a distance of barely 4.6 million miles. Earth is 93 million kilometers from the Sun, in contrast. Due to Proxima b's close orbit, it receives enough sunlight to maintain temperatures that are comparable to those on Earth and support liquid water. The planet is also exposed to powerful solar winds that have the potential to destroy its atmosphere. Proxima b is thought to be tidally locked, meaning that it always appears to be the same size in reference to Earth as the Moon does. If Proxima b already has a sophisticated civilization, it might have solar panels covering its day side to generate power that would illuminate and warm the night side, which would otherwise be too cold and dark for acceptable life. Here, the JWST comes into play. Proxima b's infrared heat signature is the key to identifying the planet's atmosphere. In addition, since Hubble's successor has a strong preference for the infrared portion of the spectrum, it's possible that Proxima b's nightside city lights will always be visible to the James Webb Space Telescope. If artificial light was contained within a frequency range that was 1,000 times narrower than the starlight, Webb could detect it, even if it were just as ineffective as the technology that our society currently uses on the night side of Earth. Proxima b's day side is largely covered in solar panels because of its unusual spectral edge and ability to reflect starlight. As Proxima b revolves around its star, day and night are identical. It is warm throughout the day and cools off at night. The difference in temperature between day and night, however, depends on whether or not the planet is entirely composed of bare rock, because an atmosphere and ocean both conduct heat. In other words, the temperature difference between Proxima b's day side and its night side will be higher if there is no atmosphere. In fact, since the day side will radiate all of the energy it receives from Proxima Centauri, we can calculate the precise amount of blackbody radiation that should exist. The night side, on the other hand, will resemble a frozen form of hell as a black body. If the temperature difference between day and night is less pronounced, we can infer the presence of an atmosphere. Conveniently, it will only take the JWST 11.2 Earth days to complete its orbit around Proxima b and analyze the infrared radiation from both of its faces. In the event that Proxima b has an atmosphere, the next step will be to analyze its makeup.